Good morning. My name is Ed Ethridge. I'm the founder of Space Resources Extraction Technology. We're in Huntsville, Alabama, and we will microwave the moon to extract water. The problem is the high cost of Earth launches at $10,000 a kilogram. To land payloads on Mars and the moon is much more expensive, $100,000 versus $1 million per kilogram. But the solution is, let's not launch so much mass. Let's use in-space resources. We subscribe to the Vegas principle, Las Vegas principle. What's mined in space stays in space. Back in 2009, the L-Cross spacecraft crashed into the South Pole of the moon and proved that there are billions of tons of water at the lunar poles. This water will be used for habitation. It will be used to produce in-space rocket propellant, and water is an excellent radiation protection material. Water is the low-hanging fruit of space resources. There are large potential markets. A manned lunar outpost will require a ton of water and a ton of oxygen a year for a $200 million market. To land and ascent back off the moon would require 11 tons according to the Apollo model. That's nearly $1 billion just for the propellant. There are 400 or more communication satellites. At the end of their life, they run out of propellant. The market for refueling these satellites would be $50 million. And we have identified some Earth applications with significant markets that we could do right here. Our microwave extraction process, the microwaves will penetrate into the soil. It heats the soil, heats the water turns to a gas, to vapor, and will flow out of the soil to be captured in a coal trap. The big thing is, this is disruptive technology. The mining equipment and excavation equipment would not be required. Therefore, we can greatly reduce the mass brought from Earth to the moon and greatly reduce the cost of the mining process. Our process can be used in the 3 different venues of markets out there, the moon, Mars, and asteroids. The last 7 years I was at NASA, we developed this technology through laboratory experiments, numerical modeling. I presented at conferences and marketed to NASA high-level managers. We will continue this kind of marketing, but we will also market to the NewSpace industry to cultivate strategic partners. Our short-term goal is to build prototypes, test these prototypes in a relevant environment at Marshall Space Flight Center, integrate this into a lunar rover and test it. And the goal is to develop a short-term water mining demonstration. Our primary competition is the status quo. NASA is very risk-averse and it's very expensive. We have a competent team that can move this company forward, and we're asking for strategic partners and $500,000 over 4 years. Thank you very much. Questions? Yes.
Do you need a license from the U.S. government, and what kind of? And if you've got one, what kind of license is it? If you develop this at NASA, I guess for you.
Oh, I have an exclusive license for the patent.
Thank you.
Technology.
Can you comment on once you have the water, what are the steps at that point to make the water valuable? So do you have to partner with somebody? I mean, what exactly is done with the water for your customers that you showed, the moon companies, the asteroid companies, the Mars companies?
Yeah, this is enabling technology, and we will need to partner with companies that will transport it, convert it into propellant or whatever. So it will be a network of companies that will come together to do the process. But mine is enabling technology which will greatly reduce the cost and make it more cost-effective and efficient.
And who are those other companies? Have you thought about who they might be or who you might partner with to make that water valuable for your end customer?
In the short term, I know that there's a Canadian firm that's built this rover drilling apparatus. And NASA, I believe, they're leaning towards using this company for their prospecting missions. So obviously, they're the ones to go to first to put the microwave probe into their drilling apparatus.
I just have a question. So you've got a 4-year plan, which is fine. So what's your vision of, I guess short vision, since it's only a little time, what's your vision of what the status of this project will be at year 4? In other words, where will the industry be 4 years from now?
I visualize it being like a stage 3 after the SBIR program, where NASA would then fund the further development to go on to their prospecting mission. And obviously it's requiring NASA funding. But I'm hoping to get strategic partners that can also contribute to the development.